Okay, in this video I'd like to talk about problem number 4.79. It deals with the casino game craps. In the game of craps, a player rolls two balanced and fair dice. 36 equally likely outcomes are possible as shown in figure 4.1 on page 147. So we saw this earlier. This is a list of all of the outcomes of two fair dice. We're going to identify the following the following events, A through G. So pause the video and read through those if you need to. We're going to look at these events here, and part A asks us to calculate the probability of each of these events right off the bat. So I'm going to show my answers over here. This is problem A, and I just need to find these probabilities. So I'll just set out by making a small table here. Probability of A, probability of B, C, and so on. Okay, so since we have this table in front of us, it makes our life a little bit easier when determining these probabilities. Let's go out and find what's the probability of an event that the sum of the dice is 7. So what we're looking for are all 7s in the possible outcomes. And since there's an order to this, it's very easy to find them. There's a pattern. So here's a 7, 7, 7, 7, 7, and 7. 1, 2, 3, 4, 5, 6 different ways to roll a 7. And if we turn that into a decimal, that would be 6 divided by 36. 6 out of 36 different ways. Let's go ahead and call that probability 0.167. 0.167. How about for probability B, that the sum of the dice is 11? Okay, so the sum of the dice being 11 has to happen here or here, and that's it. So that's 2 out of 36. 2 divided by 36, that's 0.56. 0.056. Go ahead and pause the video and find the remainder of these probabilities by using this table on the right. I'll zoom out so hopefully you can see that when you do pause the video. If you need to go to your textbook to find this display, then please do so as well. Okay, these are the probabilities that I got. Again, I counted the number of possible outcomes and divided it by the total possible outcomes for the event. So the next question here, part B, asks us or tells us that the player wins on the first roll if the sum of the dice is a 7 or 11. Find the probability of the event by using special addition rule and your answers from part A. Well, the reason why we can use the special addition rule is because these two events are mutually exclusive. A 7 or 11, so that would be event A or B. We know that these are mutually exclusive because on the first roll you can't roll a 7 and an 11 at the same time. You only have one roll. You can't roll them both at the same time. So because of that, because the two events can't occur at the same time, that's how we know that they are mutually exclusive. So all I have to do is add together the probability of A and the probability of B to determine the probability of winning on your first roll. So probability of A is 0.167 and the probability of B is 0.056. The sum of these two probabilities is 0.223. So the probability of a 7 or 11 on your very first roll, thus winning on your first roll, is a 0.223 probability, or approximately a 22% chance. Let's look at this other scenario. The player loses on the first roll if the sum of the dice is a 2, 3, or 12. So 2, 3, or 12. So probability of rolling a 2 or a 3 or a 12 on the first roll means that you lose. Now, are these events mutually exclusive? You should be asking yourself that right off the bat. And the answer is yes, because on the first roll, you can't roll a 2 and a 3 and a 12 at the same time. There's no way for you to have two of those outcomes on a single roll. So therefore, these are mutually exclusive. We can use the special rule for probability addition, and that's equal to the sum of these three probabilities. Probability of C was 0.028, D was 0.056, and E is 0.028 again. Now to sum these together, 0.028 with 0.056 with 0.028 comes out to be a 0.112 probability. Or about an 11% chance that you lose on the very first roll. Now in our next scenario, we're asked to compute the probability that the sum of the dice is 8 or doubles are rolled without using the general addition rule. So for this, we have to go back and look at our sample space. So I'm going to look at the sample space and try to find the total or the sum that adds to 8 and all of the doubles. So let's first find the doubles. Those are easy to pick out. We've got them down the diagonal here. So there are 6 doubles. And then I want to find all of those that sum to 8. So here's an 8, 8, 8, and 8. So it looks like there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 events that were either a sum of 8 or doubles being rolled. So for D here, that probability of a sum of 8 or doubles, wait, I think we've got event names for these. So sum of 8 was F and doubles, so that's F or G. The probability of F or G occurring was equal to 10 out of 36 when I counted, and 10 out of 36 is equal to a 0.278 probability. Or about a 27.8% chance of rolling an 8 or doubles. So I'm not real familiar with the game of craps. That must mean something. If you roll an 8 or doubles, that must mean something in the game. So if we try answering the same question, this time using the general addition rule, let's see what we get. The general addition rule says that the probability of F or G occurring is equal to the probability of F plus the probability of G minus the probability of F and G occurring at the same time. So in this case, the probability of F we said was 0.139, and the probability of G was 0.167. And the probability of F and G occurring at the same time, well, this one can happen, right? We can have a double and a sum of 8. There's one instance where two dice roll to be a double and their sum is equal to 8. So that's 1 out of 36, right? Because the 4 and the 4, that's the double that adds to 8. And that's the only time it can happen. So 1 out of 36 we said is a 0.028, 0.028. 0.028. So the probability independently occurring are added together. The probability of the two occurring simultaneously is subtracted. And so when I run the numbers here, 0.139 plus 0.167, take away 0.028, we see 0.278. And wouldn't you know it, these two match. It's exactly what we were hoping for. Whether you use the general addition rule or if you simply look at your sample space to obtain your result, the answers are the same. So I hope this series of videos helps you to better understand the general addition rule for probabilities as well as the special addition rule for probabilities. Be sure to look at the classroom activity assignment that was given to you today. Here, I have it listed down here. The classroom activity for October 20th. Go ahead and look at that and continue practicing through those problems to further reinforce the idea of the general and special addition rules. And I will see you all tomorrow. Thanks.